No. I think I have to repeat this. I've been talking, but I thought that I was recording. Unfortunately, I haven't been recording. I've been explaining a lot of things, thinking that making sense like that. So where did we stop? We stopped on this explanation of propanol and propanol. Hope it is being recorded. Propanol and propanol. Yeah, propanol and propanol. So we are able to see that propanol is more reactive than propanol. Why? Propanol has one alkyl group, the ethyl group here in black. So it imposes less steric hindrance. It imposes less steric hindrance, and it also imposes less inductive effect. However, for propanol, you have two alkyl groups. And what are those? The methyl groups. The ones you are seeing here in black, they offer too much steric hindrance. Therefore, we have low rate of reaction. So as a result, we say that propanol is more reactive as compared to propanol towards nucleophilic addition reactions. So what does this imply? In general, if we have more alkyl groups or hydrocarbonic groups, the more we have alkyl groups or hydrocarbon groups, the more we have bulkiness. And the more the bulkiness, the low rate of reaction. Now I have some questions here for you to reflect on. Like here in the first bullet, we have butanol, followed by propanol, followed by ethanol. Can you arrange these compounds in order of increasing or decreasing rate of reactivity towards nucleophilic addition reactions? For example, for the first bullet, I want to claim that ethanol is most reactive, followed by propanol, and lastly, butanol. Moreover, this will be my order. Ethanol is greater than, propanol is greater than butanol. Why? Look at ethanol. Ethanol is made up of one ethyl group. Look at propanol. Propanol is made up of one ethanol is made up of one methyl group. Propanol is made up of one ethyl. This one in black, look at two, black. Then three, we have two alkyl groups, ethyl and methyl. So where you have one alkyl group, in fact, in all of them, in all the three compounds, we have steric hindrance. In all the three compounds, we have steric hindrance. We have positive inductive effect. But for one, we have the methyl group. The methyl group should offer least positive inductive effect towards carbonyl functional group. I repeat, the methyl group, or the group which is small, should offer least positive inductive effect. Therefore, it should offer least bulkiness. Therefore, it should offer least steric hindrance. Therefore, it should offer much rate of reaction. Now look at three. We have two alkyl groups. Ethyl and methyl. You expect much steric hindrance. You expect much positive inductive effect. You expect much bulkiness. You expect least rate of reactivity. Then for bullet 2, we have propanol, ethanol, methanol. All of them are aldehydes. So I want to say that methanol is number 1, followed by ethanol, followed by propanol. Moreover, for bullet 2, methanol reacts faster than ethanol, which reacts faster than propanol. Look at methanol. Number 1, methanol has a structure. It has this structure. That is methanol. The carbonyl carbon is surrounded by hydrogen atoms. Hydrogen atoms do not have positive inductive effect. They can impose some little bulkiness, but very little. It can as well fail to exist. Moreover, with time we shall see that if you check on the net, methanol is a gas. You expect gases to react faster than liquids and solids. So it moves freely. So methanol is least affected by bulkiness. It is least affected by bulkiness. We have nothing to do with positive inductive effect. Therefore, it should impose high rate of reactivity, or it should have high rate of reactivity towards nucleophilic addition reactions. Look at 2-ethanol. I have a methyl group. Therefore, for that case, I have some bulkiness. I have steric hindrance. I have positive inductive effect. Therefore, rate of reaction decreases. Look at the third one. For the third one, I have a methyl group. And the third one is called propanol. The third one is called propanol, where I have an ethyl. Sorry, I have an ethyl. And that ethyl group imposes much steric hindrance, imposes much bulkiness, imposes too much positive inductive effect. Therefore, I have this reactivity. Bullet 3, I have benzaldehyde. I have benzaldehyde and diphenyl methanol. Benzaldehyde and diphenyl methanol. Now, these are aryl groups. Aryl groups haven't mentioned anywhere that aryl groups have positive inductive effect. Let me hope you are not misinterpreting what I am saying. Aryl groups, there are two groups which I have been referring to. Maybe to take you back. And what are those groups? I've been mentioning carefully hydrocarbony. You see, it is here. I don't know which color is this. Is it purple? I've been mentioning hydrocarbonic groups or alkyl groups. We can have hydrocarbon, for example, aryl. Still alkyl is still hydrocarbon here. Yeah. So here I have aryl groups. These are not, the phenyl groups are not alkyl. Therefore, they are aryl groups which are bulky. They are bulky, so they do not have nothing like inductive effect. They do not have positive inductive effect. Yeah. For them, we discuss about them in terms of bulkiness. In terms of bulkiness, therefore, you expect this. You expect this compound, this one here, diphenyl what? Diphenyl methanol, to have the least rate of reactivity. To have the least rate of reactivity because for it is made up of two bulky groups. Two bulky groups that offer too much steric hindrance. That offer too much steric hindrance towards reaction occurrence, as compared to this other compound in black. This other compound in black, which is made up of one phenyl group. Therefore, in this case, benzaldehyde comes first, followed by diphenyl methanol. So the key takeaways, I have been able to highlight in each case what comes first, followed by the other, and what comes last. Can you please kindly attach explanations? Attach explanations to those respective orderings. Attach explanations. I have been able to work out one example. I've been able to work out one example for comparison of propanol and the propanol. It is here, and I have been able to work out it exhaustively. Therefore, follow this explanation to attach explanations to those questions which I have told you to reflect on. These questions are here down. But what are the key takeaways? One of the key takeaways is that when you have more, this is the key takeaway, more alkyl groups should imply more positive inductive effect, more positive inductive effect. More alkyl group should imply more positive inductive effect, and therefore this should imply more bulkiness, and therefore this should imply less reaction rate. Then also, the opposite is true. For less, if where I have more, I put less. Less alkyl groups should imply less positive inductive effect, should imply less bulkiness, should imply more reaction rates. Hope I've made myself clear. I have said if where I have more, I put less. I have less alkyl groups, less positive inductive effect, less bulkiness, more reaction rates. Still, I can have other groups which are not alkyl groups. And for that case, I can now generalize and I say that more hydrocarbonic groups should imply more steric hindrance, should imply more steric hindrance. More steric hindrance should imply more bulkiness. More bulkiness. Therefore, this should imply more bulkiness, less reaction rate. The opposite is also true. The opposite is true. What do I mean? If you say less hydrocarbonic groups, less steric hindrance, less bulkiness, more reaction rate. You can also generalize this to a real life situation. People who are fat, depending on the context which you are exploring, people who are fat, they do not run fast. They are affected by that, their bulkiness. They work out things at a slow rate. They cannot walk fast. They eat slowly. They cannot run fast. People who are fat. So they generally have low rate of interaction with others. Particularly if I look at the social context, things of playing. However, if you are thin, small, you interact easily. You run fast, walk fast. So you have a more rate of reaction. As of now, allow me first to stop this here.